topic number 40, that is binary to hexadecimal conversion. So let's move on. Binary to hexadecimal conversion. So in the previous video we have learned that how to convert a hexadecimal number into binary number. Now in this video we are going to learn about the conversion of a binary number to hexadecimal. So let's look at. So number system. So number system has been classified into these four categories, that is the decimal number system, binary number system, octal number system and hexadecimal number system. And we have also learned that the base of a decimal number is actually 10, the base of binary number is 2, the base of octal number is 8 and the base of hexadecimal number is 16. Okay. After that we have learned that the conversion of a decimal into binary and binary into decimal. Then after that we have learned the decimal into octal number and octal number into a decimal number. Then binary number into an octal number and octal number into a binary number. Then we have learned about the conversion process of a decimal number into an hexadecimal number and a hexadecimal number into a decimal number. Okay. Now in this video we are just going to learn about the conversion of a hexadecimal. Okay. That is the conversion of a binary to hexadecimal. Okay. Binary to hexadecimal. Here you are saying that we have to convert the binary number into a hexadecimal number. Okay. So let's look at that how to convert a binary number into a hexadecimal number. So let's look at binary to hexadecimal conversion. So I have a question that I have to convert this binary number into a hexadecimal number. Okay, we know that the base of binary is 2. We know and we have studied that the base of binary is 2. And we have also know about the fact that the base of hexadecimal number is 16. Okay. And we have also learned about the rule in the previous video about the conversion of a hexadecimal into a binary number. And in that rule we have studied that for representing a hexadecimal, we can say that for representing a digit in a hexadecimal, you have to use 4 bit, and that is so clear. The rule is clarifying us for representing a digit in a hexadecimal, you have to use 4 bits, and that is so clear. And we will use that rule for solving this question. Okay, and what was rule? The rule was saying us that for representing a number in a hexadecimal, you have to use 4 bits. Therefore, here you are seeing that I have a binary number and I have to convert it into a hexadecimal number. Therefore, for representing a digit in a hexadecimal, here you will see that for representing a digit in a hexadecimal number, I have to use 4 bit. Therefore, I will use 4 bit for representing a digit in a hexadecimal number. And in the same way, for representing a digit in a hexadecimal number, I will again use 4 bits. And this is how we can solve any question related to binary to hexadecimal conversion or hexadecimal to binary conversion. Because the rule is clarifying us that for representing a digit in a hexadecimal number, you have to use 4 bits, and that is clear. So here, that is the binary number and we have to convert it into a hexadecimal number. And therefore, the rule is clarifying us that for representing a digit, you have to use 4 bit. Therefore, I am using the 4 bit. Again, in the same way, I am using 4 bit. So, actually, 2 ka power 0 into 1 is actually 1. 2 ka power 1 multiplied with 1 is actually 2. 2 ka power 2 multiplying with 1 is actually 4. And 2 ka power 3 multiplying with 1 is actually 8. So 8 plus 4 plus 2 plus 1 is actually 15. So this 4 bit is going to carry the value that is 15 here, and we know that the value of 15 in hexadecimal number is of and 4 capital F. Okay. Therefore I will write capital F because I have to represent this number, this binary number into a hexadecimal number, and we will follow the properties of the hexadecimal number. And because the value of 15 is only for the representation of capital F in hexadecimal number. Okay. Then again I am using the 4 bit for representing a digit, that is 1 here. Therefore, I will use this 4 digit, that is 2 power 0 multiplying with 1 is actually 1. 2 power 1 multiplying with 0 is actually 0. 2 power 2 multiplying with 0 is actually 0. And 2 power 3 multiplying it with 0 is actually 0. So adding this all the 4 bit, that is 0 plus 0 plus 0 plus 1 is actually 1. Therefore I am writing 1. Okay. Therefore, the binary to hexadecimal conversion has been done now. So this is how you can convert a binary number into a hexadecimal number. And this is the hexadecimal number because its base is 16 and its range is from 0 to 9 and from capital A to capital F. Therefore, this is how we can represent a binary into a hexadecimal number. We can represent a binary in hexadecimal number because of the rule, and that is saying us for representing a digit in hexadecimal, you have to use 4 bit. For representing a digit in hexadecimal, you have to use 4 bit. And this is how we have uses that concept, and through that we have find our hexadecimal number. Now let's look at the another example. And we have another example which have a decimal point also. But in the previous example, here you will see that here there is no decimal point. Okay, but here there is a decimal point. So I have to convert, because this is also a binary number, and we have to convert this binary number into a hexadecimal number. So this is another example. Okay, but we will follow the rule, and the rule is clarifying us for representing a digit in hexadecimal number, you have to use 4 bits. And that is clear for us. For representing a digit in hexadecimal, you have to use 4 bit. Therefore, I am using this concept for solving the binary number into a hexadecimal number. So, the rule is clarifying us that for representing a digit in hexadecimal number, you have to use 4 bit. Therefore, I am using that concept. So, 2 power 0 multiplying with 0 is actually 0. 2 power 1 multiplying with 1 is actually 2. 2 power 2 multiplying with 0 is actually 0. 2 power 3 multiplying it with 1 is actually 8. So adding all this term, that is 8 plus 0 plus 2 plus 0 is actually 10. And we know that the value of 10 in hexadecimal number is actually capital A. Therefore I will write capital A for the value that is 10 here. And in the same way, we will proceed further and we will represent a digit in 4 bit. So 2 power 0 multiplying it with 0 is actually 0. 2 power 1 multiplying it with 1 is actually 2. 2 power 2 multiplying it with 0 is actually 0. And 2 power 3 multiplying it with 0 is actually 0. So 0 plus 0 plus 2 plus 0 is actually 2. So this 4 bit is representing a digit, that is 2 here. So we will present it here, that is 2. And in the same way, we will write for 30, that is capital D. So 2 ka power 0 multiplying it with 1 is actually 1. 2 ka power 1 multiplying it with 0 is actually 0. 2 ka power 3 2 ka power 2 multiplying it with 1 is actually 4. And 2 ka power 3 multiplying it with 3, that is multiplying it with 1 is actually 8. So adding all these we get 8 plus 4 plus 0 plus 1 is actually 13. And we know that the value of 13 in hexadecimal number is capital D. Therefore, this is how we can represent a digit in 4 bits. You have to use, you can represent a digit in hexadecimal number by using 4 bit. Therefore, I am using that concept. And in the same way, we will proceed it further for this digit again. So 2 ka power 0 multiplying it with 0 is actually 0. 2 ka power 1 multiplying it with 1 is actually 2. 2 ka power 2 multiplying it with 0 is actually 0. And 2 ka power 3 multiplying it with 0 is actually 0. So adding all these, we get 0 plus 0 plus 2 plus 0 is actually 2. So this is how we can represent this digit in these bits. That is, for representing a digit in hexadecimal number, you have to use 4 bit. So this is how we can solve the problems related to the conversion of a binary into a hexadecimal number. So this is our output 2D.2a whole base 16. So this is a hexadecimal number. So this is how we can convert a binary number, or we can say the fractional binary number into a hexadecimal number. So this was all in binary to hexadecimal conversion. So thanks for watching. धन्यवाद.